Hi, good afternoon everyone. My name is Bontile from 11 STEM Gauss, and I will be explaining how I got my solutions for the video output number 1. So for the video output number 1, we have two questions with 3 scenarios each. So for number 1, the question is the average length of adult rabbits is 30 cm with standard deviation of 4 cm if their lengths are normally distributed. So for number 1, there are 3 scenarios that are needed to be solved. So for A, how many percent of adult rabbits are shorter than 28 cm? For B, how many percent of adult rabbits exceed 40 cm in length? Number C is if a rabbit is randomly chosen, what is the probability that its length is between 21 cm and 35 cm? So for A, this is how I solved it. So first, I wrote down all of the numbers or all of the given numbers that are needed for the solution. So I wrote down the mean, which is 30, the standard deviation, which is 4, and the x, which is 28. So next, I wrote down the equation that is needed for the solution. So that is z is equal to x minus mean all over the standard deviation. After that, I substituted the signs. I substituted them for their respective values. So it became z is equal to 28 minus 30 all over 4. So 28 minus 30 is negative 2 divided by 4. It became negative 0.5. So after that, we will get the value of negative 0.5 from the z-score table. So if you will look at the negative table for the z-scores, negative 0.5 is equivalent to 0.3085. So to get the percentage of 0.3085, we need to multiply it with 100. So it is 30.85%. So the answer for letter A is there is 30.85% chance that adult rabbits are shorter than 28 cm. So for B, how many percent of adult rabbits exceed 40 cm in length? So like the first scenario, I also wrote the given numbers that are needed for the solution. So the mean is 30, standard deviation is 4, and x is equal to 40. So next, I also wrote the equation that is needed, or the formula that is needed to solve this scenario. So it is z is equals to x minus the mean all over the standard deviation. So I just substituted them for their respective values. So it became z is equal to 40 minus 30 all over 4. So 40 minus 30 is 10 divided by 4, it is 2.5. So if you will look at the z-score table, the 2.5 is equivalent to 0.9798. So since we are being asked how many percent of rabbits exceed 40 cm, we will need to use the technique in getting the z-score above. So we will subtract 1 from 0.9798. So 1 minus 0.9798 is equals to 0.0202. So now to get the percentage, we will also multiply 0.0202 to 100. So it will become 2.02%. So the full answer is there is 2.02% chance that adult rabbits exceed 40 cm in length. So that is the answer for the scenario B. So for the last scenario, which is C, if a rabbit is randomly chosen, what is the probability that its length is between 20 cm and 35 cm? So for this, we will solve for two z-scores. So before I did that, I also wrote the given numbers that are needed for the solution. So for the first one, the mean is also the same, which is 30. The standard deviation is 4, and the x here is 21. So like the earlier scenarios, I also wrote the formula that is needed, which is z equals x minus the mean all over the standard deviation. Then I substituted their respective values in this scenario. So it became z is equals to 21 minus 30 all over 4. So 21 minus 30, it is equals to negative 9. So negative 9 divided by 4, it is negative 2.25. So if you will look at the negative z-score table, negative 2.25 is equivalent to 0.0122. So that is our z-score for the first part of this scenario. So now we will get the second z-score. So like the earlier one, I also wrote the given numbers that is needed for the solution. So the mean is also the same, it is 30. The standard deviation is also the same, it is 4. X is equal to 35. So I also substituted their respective values to the given formula. So it became z is equals to 35 minus 30 all over 4. So 35 minus 30, it is 5. 5 divided by 4, it is 1.25. So if you will look at the positive z-score table, 1.25 is equivalent to 0.8944. So to get the final answer for the third scenario, we will minus the z-score of the first one we solved and the second z-score. So it will become 0.0122 minus 0.8944, and it will become 0.8822. So to get the percentage, we will also multiply 100 to 0.8822. So it will become 88.22%. So the final answer is there is 88.22% chance that the rabbit that's randomly chosen will have a length between 21 cm and 35 cm. So that is the final answer for the third scenario. So moving on to the second question for the video output. A coffee vending machine is designed to discharge an average of 8 ounces with a standard deviation of 0.2 ounces. If the amount of coffee the machine discharges follow a normal distribution. So like the first question, it also has 3 different scenarios that we will need to solve and discuss. So for letter A, or the first scenario, what percent of the discharges exceeds 8.5 ounces? So like the first ones, I always write the given numbers that are needed in the solution. So first is the mean. Their mean is 8, the standard deviation is 0.2, and the x is 8.5. So we will write the formula, which is z is equals to x minus mean all over the standard deviation, and then we will substitute the respective values for this scenario. So it will become z is equals to 8.5 minus 8 all over 0.2. So 8.5 minus 8 is 0.5 divided by 0.2, it is 2.5. So we will look at the z-score table, and 2.5 is equivalent to 0.9798. So because we are looking for the percent that exceeds 8.5 ounces, we will subtract 1 to 0.9798. So 1 minus 0.9798, it is equal to 0.0202. So to get the percentage, we will multiply 0.0202 we will multiply it to 100. So it will become 2.02%. So the final answer is there is 2.02% chances that the discharges exceed 8.5 ounces. So moving on to the second scenario, what percent of the discharge are between 7.6 ounces and 8.1 ounces? So for that, we will solve for 2 z-scores. So like the previous one, I wrote down the given numbers that are needed for the solution. So the mean is 8, the standard deviation is 0.2, and the x for the first z-score is 7.6. So we will also substitute these numbers to the formula that is given to solve for the z-score, which is z is equals to x minus the mean all over the standard deviation. So z, it will become z is equal to 7.6 minus 8 all over 0.2. So 7.6 minus 8, it will become negative 0.4. So negative 0.4 is divided by 0.2. So it will become negative 2. So in the negative z-score table, negative 2 is equal to 0.0228. So that is the first z-score. So moving on, for scenario B, we will solve the second z-score. So for the second z-score, I also wrote there the given numbers that is needed to solve this solution. So we have the mean and the deviation, which is the same. The mean is 8 and the standard deviation is 0.2. So for the x in this z-score solution, we will use 8.1. So we will substitute those values for the formula, which is z is equals to x minus the mean all over the standard deviation. So it will become z is equal to 8.1 minus 8 all over 0.2. So 8.1 minus 8 is equal to 0.1. So 0.1 divided by 0.2, it will become 0.5. So if you will look at the z-score table, 0.5 is equivalent to 0.6915. So now that we have the two z-scores, to get the final answer in the second scenario, we will subtract them. So we will subtract 0.0228 to 0.6915. So 0.0228 minus 0.6915, it is equals to 0.6687. So to get the percentage of that, we will multiply it to 100. So it will become 66.87%. So the final answer, there is 66.87% chance that the discharges are between 7.6 ounces and 8.1 ounces. So for the final letter, or the final scenario in this question, if a customer buys a cup of coffee, what is the probability that it is less than 7.7 ounces? So we will also write the given numbers, which is the mean is 8, the standard deviation is 0.2, and the x is 7.7. So we will also write down the formula, which is z is equal to x minus the mean all over the standard deviation. So we will substitute the values, the respective values, to the formula. So it will become z is equal to 7.7 minus 8 all over 0.2. So 7.7 minus 8, it will become negative 0.3. Negative 0.3 divided by 0.2, it will become negative 1.5. So if we will look at the negative z-score table, negative 1.5 is equal to 0.0668. So to get the percentage of that number, we will multiply it to 100. So it will become 6.68%. So the final answer is there is 6.68% chance that the probability is less than 7.7 ounces. So that that is how I solved the solution for the video output that is assigned to our class. So I hope you understood what I said and how I got it. So thank you for watching. Have a great day ahead.